All right. Hello. Welcome, everybody. Let me know if you guys can hear me. Say something in the comments. Um, I tested everything out. Okay, cool. Tested everything yesterday, but you just never know. Let me know how the stream quality looks. It says right here it's at 4,000 bytes, but YouTube's telling me that it's at, you know, 2,000 kilobytes. So yeah. All right. OBS tells me it's green. YouTube is screaming at me, so hopefully it looks okay, especially because you guys are going to be reading a lot of text. So I want to make sure the quality looks good. 1080 60p? Great. That's exactly what I set it at. Okay, cool. All right, so everybody, welcome. So today is the first day of this really, what's going to be like, what, 2 months? All of June, July, and basically most of August. I'm going to end it probably either the week before school starts or I will end it on the first week of school when you guys go back. Usually the first week of of university, there's not much going on unless you're taking like physics and then like you have lecture day one. So, hopefully it doesn't happen. Um, okay. So currently right now, oh yeah, if you can also sign in, if you look at the description um, of the live feed, there should be a link. I will post the link on in the chat. I can already see that a lot of you guys have already started um, signing in, so that's great. So I will just post it in the chat. I also post it in the Discord server, so you can go ahead and just, sign in. That would be great. Say what's up, everybody. Herman's here, so that's cool. Um, so um, this is, not for just Sac State students. This is for, basically anybody that wants to learn about, software development. Um, there was a vote that was taken, like last month or something like that. I forget. And I had two options: mobile development, like native mobile development, using something like Android or Xamarin, or like doing like uh, a web development. More an emphasis on web development, which is a very popular stack, is the MERN stack, based off of interviews that I've had, interviews that some of my other friends have had, and just the general way that the industry is going. Understanding the MERN stack is going to give you a gigantic leg up when it comes to you going into that interview, or even before you even get an interview, talking to one of those recruiters at those career fairs, and whether they want to actually give you the interview or not, when they ask you some of these very basic questions. um, this entire summer is going to be dedicated into going basically from a zero to a hero. And if you already know some stuff, this should all just be review. And there's going to be some things that hopefully you learn, things like Tailwind, some cool design patterns that we're going to use in React. Um, that's, some questions may arise depending on what your skill level's at. And so I'm going to try and go over a lot of interview type questions that I have been asked, that I know other people have been asked. I'm going to present them to you, which can be the difference between getting that interview, not getting that interview, or getting the job and not getting the job, right? So I'm not going to do any leak code stuff. I personally don't like it, um, but I can see that a lot of companies do ask, leak code stuff. I think if you just practice, a lot of it you should be able to figure out as you go. But I will say that if you're trying to work for like one of those big companies, like, they call it the FANG companies, then you should, during the summer, as you're going through this course with us, you should be using LeetCode or insert whatever website and really grind that stuff out. There's a book called Cracking the Interview or something like that. I heard that book is really really good. You should take a look at that. It talks a lot about things like backtracking and stuff like that, which is techniques to solve certain types of algorithm questions that are asked at these really big companies. So again, I just want to emphasize what this session is going to be and to set up expectations. Um, I'm not going to touch the leak code stuff. Maybe we'll touch some stuff of maybe some things that I find interesting. But for the most part, I'm not going to touch that because I personally hate it. But for your own sake, you should probably do it. Okay? Cool. All right. So now that that's out of the way and people are signing in, I'm gonna just put it in the chat one more time. Just please sign in. I will have the forms always available to sign in at the beginning of the streams, and I will close the sign in at 10 after. So the purpose of the sign in, again, the session is completely free. So go ahead and spread the word to anybody else that wants to learn, even if they're not in computer science or they're not even in Sac State. Spread the word. This is to help people get into web development or just software engineering in general. Okay. Um, so David is asking, is LeetCode or HackerRank better? They're basically doing the same thing. They have the same end goal. I think there's just different forms of like premium subscriptions. I think you can pay for some of them, and then they'll give you like answers to really hard questions or stuff like that. But I've used HackerRank, and it's pretty good. It's got a nice interface, so it's pretty nice. Okay, cool. See, what else do we gotta go over? I think that's it. Do if you're not a Discord user, make an account and then join our Discord server. The Discord link should be in the description of the video. And what I'm going to do is I want this to be as quote unquote live as possible. So what's going to happen is if there's a question that is asked, right? You guys, we're doing this on YouTube. You can totally put it in the chat. But, if more context is required, if it's easier to talk, between us, I'm going to have it so you can hop onto the Discord server. We can go into a voice chat and, everybody on YouTube can hear you asking the question and we can have this conversation essentially live, just so we can emulate being in a classroom setting because of COVID, everything's, virtual now. So that can be kind of a problem. So I want to try and have a balance there. So, all right, cool. All right, so I think with that, I guess we'll just start with a, very simple presentation here. And basically, what is SoDA? So who am I? So my name's Kevin Pacheco. I graduated from Sac State University this past December, so I'm a 2020 alumni. I got my bachelor's in computer science. I got my certification in cyber defense, and I also got a minor in mathematics. And I'm the president and founder of SoDA, which stands for the Software Developers Association. Okay. And I have Victoria, which is basically acting as the community manager for the organization. So she graduated in 2020 as well in December. So we're both alumni. She received her bachelor's also in computer science. And if you ever need help, reach out to her. She's in the chat, and she's also the Discord server. And my good friend here, Corbin, cool dude, very funny, incredibly smart. Okay, he's got, I think this should probably be now at 6 years or 7 years now. He's a full stack developer. So if you ever have any specific questions or whatever, just put it in the Discord chat, and either I or he can answer, any kinds of questions. So, do utilize the chat in Discord, because he will answer at some point. He's usually pretty fast about it, and yeah, I mean he loves it. He also runs a site called Unicorn Utterances, and there he blogs about just software development stuff, right? Things that he's learned, things that he's just seen in the wild, and just his opinions on things, and just kind of guiding newbies how to navigate this plethora of coding stuff that's out there. So he has an awesome blog called Unicorn Utterances. It's very nice. And yeah, so definitely check that out. Yeah, so what is SoDA? So, again, SoDA stands for Software Developers Association. We are no longer a Sacramento State University club. I kind of want to separate things out, but because I'm a Sac State alumni, I have an emphasis on Sac State students because, that's uh, that's my school. So we're now focused more as an educational organization. That's kind of where I want to take this, right? So I want to, help people learn about software development. It's open to everyone, so you don't have to be a computer science and you don't have to be a Sac State student. We're trying to do like a lecture and hands-on strategy here. So it's not just going to be me talking and a bunch of slides. It's going to be like we're going to be coding a lot of code. So our focus is just to share knowledge and focus on practical applications, like actually building things that if you were to have, a job, these are like we're going to be doing the things that they're going to be asking you to do, like what your tasks are going to be. We will be doing them, so you can see what that's like. So when you do land that job, you're not like all of a sudden overwhelmed, like oh no, I don't know what to do and stuff like that. So that's where our focus is at. Is just straight skill building. Okay, you're at university to learn the theoretical. If you join us, we're going to be building skills here. So that's a different emphasis. So our mission is to help prepare up-and-coming developers gain the skills required for today's workforce. So again, MERN is this new popular thing that's going around, right? We have Express, we have React, we have Node.js, we have Mongo, we have MySQL stuff. All great stuff that, if you get a job, you're going to be touching one of these technologies for sure. Okay, so we take what we know of a theoretical setting and apply it to a practical skill building. So when you hear about MVC or MVP or MVVM or object-oriented, composite, design patterns, strategy patterns, all these kinds of patterns that you hear them in your lectures and tell you what it is, but then you never really do anything with it. Well, in here we're going to be doing stuff with it. And we just want to pass on the stuff that we've learned. So knowledge should be open and available for everyone. That's what I believe. Okay. All right, here's some important links. Okay, so you have the Discord link. We have Google Drive where you can find these slides. If you join the Discord server, all these links are going to be under important links. And so you can catch all that there. So we have the GitHub, we have the YouTube, and the Unicorn Utterances blog from Corbin. Cool, and that's about it. So if you have any questions, hit us up on Discord. I'm Polymorphic on Discord. We have Victoria, who's Ice, and Corbin, who's Crutchcorn. Okay? Hermans has a quick question, just in case. What is your opinion on iOS development? Is it a risky route to take? Is it worth taking? It is not risky. Every company has a mobile app, basically, and they're always looking for native developers. No matter if you're going to be doing stuff with React Native, or you're doing some kind of like Flutter or anything like that, you are always going to need a native developer at some point in the chain. You will need a native developer. So if you want to learn iOS development, there's always going to be a job somewhere for you at some company working on mobile development. I will say that don't just do iOS. Do iOS as like the bare bones where you can actually get bare metal, which is like native. That's what we call native. But then learn a framework on top of that, like Flutter, and then use your iOS development knowledge so you can build plugins that get access to native specific behaviors and expose them to Flutter, right? Or React Native, for example. And I think that would be a a better approach. So do the native, whether it's iOS or Android, but then also pick a framework that you like, or a company that you want to go work for is using, like Flutter or React Native. So do both. Definitely do both. Okay. Okay, so that's it for that. Okay, so what else do we got here? Okay, and so here is this other presentation I want to go over real quick. And basically, this is called, what is MERN? Because this is what we will be focusing on over the entire summer. So let's talk a little bit about what this is. So, okay, so first of all, what is a tech stack? You're always hearing about, oh, hey, what's your favorite tech stack? Or, yeah, the tech stack that we use at this company is blah. And so, like, what are they always talking about? What does this actually mean? And so tech stack is just a technology stack, which is just a set of frameworks, languages, and tools used to develop a software product. Let's say your product is supposed to be on the web or mobile, or maybe it's a video game, or something like that. So some examples is like the MERN stack, which is what we're going to be focusing on. There's one called the mean stack. There's the LAMP stack, which Facebook actually, when it was first being developed, actually used the LAMP stack, which is very famous, which is the Linux, Apache, MySQL, and PHP and Perl. So for those of you guys that used Facebook in the beginning, you will have noticed that the pages always ended in PHP. That's because the entire Facebook website, the entire stack was built on PHP, Linux, and Apache on MySQL. Okay, they've now moved on to like using. There's still parts of it that's still using the LAMP stack, but they're now using React since Facebook created React. They're using React instead of like MySQL. A lot of it has been moving to GraphQL, stuff like that. A lot of these technologies that they've invented because of the social media I used to call it, the problems that comes when you have friends of friends. You have like this really deep web, so they created something called GraphQL, so stuff like that. And then Venom is using Vue, Node, MongoDB, and Express. So Vue.js is just another library, a rendering library for with using JavaScript for the web. We will be using React, but Vue is another option. Okay. So let's look at the anatomy of an entire application. So when we talk about the client side or the front end, what we mean is the front-facing program, the program that's going to be running on the computer that the user or consumer or whatever is going to be using or interacting with. So sometimes you can download to a user's device, such as an app. And nowadays we have PWAs, progressive web apps. It could be a website. It's usually interactive, right? There's a user interface, which is called a UI. There's buttons, there's input, stuff like that. And then we have a server, or sometimes what we call the back end, right? That holds the business logic, resource serving, like data, web pages. In the case of like something like Instagram, it holds all the images, it has the user profiles, the text, stuff like that. It can also do computations like image processing. So when you upload a video to YouTube or to, the talk ticks, you send a video up there, it's got to process that, it's got to compress it, whatever, so that you're sending it to a whole nother server, and it's doing that. It also holds the database, okay? And it can communicate using something called SOAP, or RESTful Web Service, okay? And we're going to be talking about the difference between these two. And in fact, SOAP versus REST, that's actually a question that comes up on the interviews. They'll ask you, hey, what's SOAP? Hey, what's REST? Hey, what's the difference between the two? And that's how they know whether or not you've actually ever built something. Because if you don't know the answers to that, you haven't built anything complicated enough yet. But we will be doing that here. So this is what a client-side web stack kind of looks like. So the technology built itself from a bottom-up approach. So we start with the bottom. Okay, that's the hardware for the client. That's a laptop. That's a phone, something like that. And then on top of that hardware, okay, we have something that's probably going to be interfacing, that's running that program, like a browser. Let's say we have a browser, so it could be Safari, Chrome, or a web view. Okay, and then this program, Safari, Chrome, web, and these web views, they're just programs, right? So web view lives inside of these, Safari and Chrome, or a web view could be like on an Android application that runs a web view on top of it. Okay. And then the browser just has the HTML, the hypertext markup language, which we're going to be talking about that. Okay. Then on top of the HTML, we have some CSS, which just, makes everything look pretty. Okay. And then with that CSS, we have some JavaScript. Okay. So these are the layers. Now looking at it like this, now let's look at it from a top to bottom approach. Or let's see what happens when we go from the top to the bottom. So the upper layers can utilize the layers that came before it. So with JavaScript, we can manipulate the CSS. We can change things. We can load in more CSS and unload CSS. The CSS cannot interact with JavaScript. There is no way for CSS to interact with JavaScript. Only JavaScript can interact with CSS. Okay? The CSS can definitely interact with the HTML. That's kind of like what you're doing. You're writing these rules, that's meant for like the HTML with the elements and the tags and stuff like that. Okay? And then the JavaScript can not only interact with the CSS, change things, but it can also directly interact with the HTML. We can do some DOM manipulations, like we can create elements, like we can create divs, we can destroy divs, we can change the data, we can change the attributes, we can listen for event handlers like clicking a button or typing into an input box. Okay? And now we have the server side, which looks very similar. It's actually very cool. So we have a machine, again, the hardware. Let's say we use Amazon EC2. It's a virtual private server, right? A VPS. That's what a VPS is. It's a virtual private server. Again, a VPS. You'll hear that word a lot when you talk about cloud computing. Oh, what's a VPS? Oh, what's your VPS? Oh, my VPS is Amazon EC2. It's just a server. It's a machine, a virtual machine that lives somewhere else, and it's given to me as a what's it called, as a service, server as a service, or something like that. Basically, I pay for it, right? I pay for it. It's not free. I pay for it, and it's a service. The service is that I get to run in Amazon EC2. Okay, cool. So on this hardware, what can I run? Well, I run my operating system. Let's say Ubuntu. That's the one I like to use. I use Ubuntu server. Okay, cool. This operating system, I have Ubuntu server. So what can my operating system then do? Well, I can run a web server, like let's say Apache. Apache being a forward or reverse proxy. We'll talk about forward and reverse proxies. And for my web server, I can have something on top of that. Let's say a database like MongoDB or MySQL, right? Yeah, Harsh has it. PA. I always forget what it is. I forget what it stands for. Something as a service. There's all these SaaS and PaaS and gas and all kinds of stuff. Where would Docker play a role? So Docker would actually play a role in the web server. That is, instead of Apache, instead of using the reverse proxy of Apache, we could use a reverse proxy using Nginx. And then Nginx would act as a orchestrator for Docker containers, which, with Nginx, we can do a bunch of things. That's like load balancing, making sure that we are distributing the workload between all the servers. You can tell Nginx, where your Docker containers are in case one shuts down. You know how to create a new one, and also where the servers are. So, Nginx, that's what it basically does. So that's kind of like where Docker would live, is somewhere in the web server. Okay, and then so we have our databases, Mongo, MySQL, and then we have a framework, let's say Node.js, or we have a raw C++ thing going on. or we're using Golang, something to create our framework for our backend. And so the framework can access the database, right? Your database cannot access the framework like Node.js. It's not how it works. So the framework can interact with the database and like request things or delete things. The framework can also access things about the web server, right? So there's like this double thing, you can do a lot of things. And the framework can also access things from the operating system, like it can save things to the file, it can read things from a file, it can change permissions if you need to do stuff like that. So you can see how the upper layers are utilizing the layers that came before. So everything is stacked up in layers. So you just need to know, where do you want to work at, So we're going to be focused basically on these two layers right here. Okay, we're going to be focused here. We will touch this a little bit. We have to spin these up, but once we have this, we're not going to really touch this and not really touch this. We're going to be working in here. Okay. All right, so let's see what a full stack application actually looks like in the wild when you're actually doing something. So, so here we have arrow number 1. Let's say you go to domain.com. Okay, so you go to domain.com. So this is not JavaScript going here. This is like, here's the client, and then here's the backend. So you go on your browser, you type in domain.com. That goes, and it has to go through the DNS, right? And it has to find the IP address that basically is part of this, what's it called, the A name, and to figure out, okay, what does domain.com map to? So what's the IP? But anyway, once it finds it, then it's like, oh, okay, you want domain.com. So here's the HTML and the CSS and the JavaScript. So the backend's going to send us all that information. Cool. So now we have some of this stuff. And let's say it's a login form. So then it says logs in. So you log in, you type in your username, your password, and you send that over to the backend. The backend takes in the username and the password, maybe looks something up in the database and authenticates you. Everything's okay. And then it sends it back to the client side, whoever did the requesting. It's like, here's the personal profile information. So you can see how this is working. There's this constant back and forth. So this is what a full stack application looks like. You have your client side on this side, and then you have your whole backend service over here, whatever that may be. You do a request, it gives you something, you use that something to maybe do another request, and it sends you back resources. So you're constantly going back and forth. So let's look at the MERN composition. What is this? So the MERN composition is usually MongoDB, which is a NoSQL document-based database. Okay, so it doesn't use SQL stuff. It's not based off that. It's based off documents, like let's say it's like JSON, so it'll be like JSON based. And then we have something called Express.js, which is a framework built on top of Node.js to build web application frameworks. Like we can build a RESTful service using Express.js, or we can have Express.js be basically our web server. We can serve HTML back and forth. So you can totally do that. And then we have React, which is a library built by Facebook to develop user interfaces using JavaScript. Okay, this is a lot different. Usually you would build your stuff using HTML and stuff like that. With React, we're going to be using JavaScript to actually be building our UIs, which is different. And then the N stands for Node.js, which is a runtime environment to execute JavaScript outside of a browser. Okay, so Node.js, they're asking an interview, hey, what's Node.js? Oh, it's a runtime environment to execute JavaScript outside of a browser. That's what it is. It's a C++ program that runs on top of the Chrome V8 engine. You feed it JavaScript and it spits something out. That's basically all it is. That's all Node.js is. That's an oversimplification, but that's basically what it does. You feed it JavaScript and it spits something out. Okay, so the difference is, MERN or mean, these sound very similar. So what are the differences? So there's overlapping technology. The M, the Mongo, you can also use MySQL. The E, which is Express. You have the N, which is Node.js. And then it comes down to React or Angular. What should you use? React or Angular? Well, you choose what best fits your team, right? Do you have a majority of your team? Is it React developers or is it Angular people that you have. That's the best way to choose. And they both have different goals. They're not the same. Okay, they're very different. So Angular is a framework. Okay, so a framework is a rigid environment. It has predefined modules for you to use. So if you want to do some HTTP requests or something like that, Angular already has the APIs for you to do that with. Okay, they kind of tell you what you have to use. Oh, you have to do it this way. Okay, that's not always a bad thing, right? It's not always a bad thing, right? With React, which is a library, it's very flexible. Okay, it's a very flexible environment. The problem is, or if it is a problem, is that now you need to find the modules yourself. Is that a good thing or a bad thing? See, with Angular, a lot of these, what module should I use to do X, Y, Z? Angular already answered the questions, like you have to use this, and then you're done. But with React, it's like, oh, okay. React only does the UI, and that's only part of your entire requirement. So now you have to figure out, okay, so what am I going to use for unit testing? What am I going to use for HTTP calls? What am I going to use for my data stores? All these kinds of, how do I keep application state? Angular has all those answers for you, which is why it's rigid, right? It kind of already tells you what you're going to be doing or using. React is flexible in that you get to choose whatever you want, but for some people that may be a problem because, oh my gosh, now I have to go figure out all these things that I'm going to need in order to build my application. So it's freedom because you have the freedom to choose, but then it can also be kind of overwhelming because now you can basically do anything you want. And so, that can be, again, the pros and cons to everything. So if you just want to check out, what's more popular nowadays, you can use Google Trends to just figure that out. Just, uh, compare React developer versus Angular developer, and you're going to see there's a massive difference between these. So React developer, that term comes up a lot versus Angular developer. Now, does this mean there are more jobs for React developer? Yeah, that could be something. It just depends on how you want to interpret this graph here. Um, I'm sure this graph is even more further apart. This was done like 2 years ago. So I bet you the graph is even more far apart now. Okay. So the stack that we will be using for the entire summer is the MERN stack. So we will use like the MERN stack. Again, each stack has its own pros and cons. So pick the technology stack that best fits your needs, your skills, the skill of your team, and your timeline. Timeline is essential. You have deadlines. If nobody knows anything of React and everybody knows everything about Angular, and you have like 2 weeks to do something, are you sure you want to risk it by jumping into React? You see what I mean? So there's a lot of factors in choosing a stack, okay? Or, anything in general. Play it based off what your team knows, what they're already used to, and go with that, okay? Okay, and that's about it for that. So that's what MERN was. Not too bad. Not too bad. Does anybody have any questions or anything so far? Blah, blah. Here we go. Would using SQL make this a different stack then? No, because okay, so the reason why Mongo is used over MySQL or some other type of database is because with Mongo, Mongo was kind of built for this. That's the cool thing. And Mongo is all in JavaScript. So you think about it. With one language, you can build your front end. You can build your back end. You can also maintain and handle your database, all in one language. That's why companies are gravitating to this because they hire a person that is like a ninja at JavaScript, and you can throw them at any one of these tasks. Do the front end, do the back end, do the database. That's what's beautiful about this stack is that it's basically JavaScript everywhere. right? JavaScript is literally taking over the world, folks. It's everywhere, okay? And it's not slowing down, okay? So, but for the purposes of the summer, we will touch MongoDB, but I still want to show you MySQL because a lot of companies are still using MySQL, or not MySQL specifically, but SQL, relational databases. That is still a huge part of a lot of companies. So I will be showing you Mongo and how that works, but I will emphasize SQL on the sole purpose that more likely than not, the company that you're going to end up working for will be still using SQL in some capacity over something like Mongo. I don't think the adoption for like big companies has hit yet, but it is getting there. Okay. If you work for a startup, it's going to be Mongo. 100% guarantee it's going to be Mongo. But for anything else, probably MySQL. All right. So with that in mind, we still have 24 minutes. So yeah, so let's do some JavaScript. Why don't we just jump right in? Okay, so if anybody has questions, again, feel free to ask questions. If not, we're just going to jump right in. Don't want to waste any time here. The other thing to note is, the software requirements I put in the server, what we're going to be needing, and we're going to be needing like Node.js and Postman, at least for now. And you can pick your own, you can pick your own, what's it called? You can pick your own editor, whether it's like Visual Studio Code, which I prefer. You could use Vim if you're crazy. That's also an option. Notepad, whatever you want. I'm using Visual Studio Code. Okay, so this is what I'll be using. Herman's saying an IDE. Yeah, I mean, technically you could use an IDE. You could use Visual Studios actually to do all this stuff too. Visual Studios has support for Node.js projects like React and Angular and just Node.js in general. So you can totally use, Visual Studio if you're comfortable with that. Has a lot of cool stuff, not gonna lie. I like VS Code because it's very lightweight. All right. So we have a user here that says they're new to programming. So not a problem. So the only software you're going to need to install is Node.js. Just go here, whatever platform you're on. If you're Linux, you probably want the source code. You can build it yourself. That's always one way. Here's the Windows installer. Just install it. You should be fine. Mac, it's pretty straightforward. Linux is the only one that's going to be, it could be a problem if you're not used to, how Linux works. But if you have a question with Linux, let me know. It's pretty easy, but only if you've done this before. If not, let me know, and I can help you. You might need to change your bash profile or your bash RC to make sure the environment variable is set to point to Node.js wherever you decide to install it in. And the other thing we're going to be needing is Postman. So we'll just need Postman here. And it's basically an application to do, test your API. Is Node.js v12 okay? Yep, that's actually the version I have, I'm pretty sure. If I do Node, yep, I have version 12. I think the newest version is 14, I believe. Let me double check that. Yeah, 14. I'm using 12, totally fine. And then Postman. So Postman is just a way for you to test your, it's just an application to test your APIs. We won't be using it right now, but it is an application that we will be using once we start getting a little bit closer to doing the backend stuff. Okay. So here's an example of like using testing out an Apple API and then just running it. So you can just run the API here and then you get your preview here. So I'll switch this over to JSON and you can see what the backend from Apple is actually sending me back. So that's pretty cool. Okay. So just wait for us to test things. And then I use VS Code. It's free and open source from Microsoft. So here it is. There's Windows. If you have Debian, it's really easy. Just download the .deb and it should automatically install. RPM. I've not used Red Hat or Fedora, so I'm assuming these two processes are the same. You can also just download it as a tar gzip and then extract it that way. That's one way. And then on Mac you have the installer, so it's pretty simple. I'm not sure if you have an M1 chip, this should still work, but I'm not entirely sure. I don't have an M1 Mac. All right, cool. All right, let's get started. So it's going to be a mixture of doing stuff like you're looking at the slides and also me running some code in VS Code. So it's going to be a little bit of both. So I just noticed on the Discord, somebody was asking Jimbo, do we need JavaScript background for this bootcamp? Absolutely not. You will be learning JavaScript from the ground up. So that's what this first session is today, is learning JavaScript. So you're totally fine. All right. So for those that are new to programming, this is going to be pretty nice slides actually, because I'm going to basically go as if you knew absolutely nothing of programming. So that's a beautiful thing. And if you know stuff about programming, you've already taken some programming classes, then this should be reviewed. So you should be okay. And if there's some things in here that you're hearing for the very first time and you're a computer science student or you're in a programming class, then you should definitely ask some more questions and review these things, because at this point, this stuff should be reviewed for you. Okay. All right, so we're going to talk about statements. What's a statement? So a statement is in a computer programming context, it's just a program. It's just instructions that are to be executed. That's what a statement is. That's all it is. So a computer program is just a bunch of instructions to be executed. And these things, we call them statements. Statements are terminated with a semicolon. Now, this is language specific, okay? Harsh asking, can we use Atom? Yeah, you can use whatever you want, whatever you feel comfortable with. You can use Atom. I forgot what the other one's called. iTerm on Mac. It's called iTerm. What's the other popular one? I forgot what the other popular one is. There's Atom and there's something else. Anyways, yeah, so statements are, in the context of JavaScript, remember, we're talking about JavaScript. In the context of JavaScript, we end statements with a semicolon. Now, technically, you don't have to, but I will enforce that you will need to terminate your statements with a semicolon, okay? You technically don't have to, but I will be enforcing that. And statements are just composed of values, operators, expressions, keywords, and comments. So we'll be going over all of this stuff. Someone's asking, will this class leave you here on your channel? Yes. So it should automatically archive. So if you can't, stay to the whole thing or you miss a day, it should be archived to the YouTube channel. So you should just be able to find it and watch it at your own time. I also have it so that the chat should auto replay. So in case somebody asked a question, you're not kind of confused as to, what the heck I'm talking about. You can see the person's questions on the live chat. So variables, what's a variable? So variables are just containers that store data. That's basically all they do. And so what's data? So data are just the characteristics or information, usually numerical, that is collected through observation. So that's what data is, right? So for example, we have a glass cup, which is an empty container. You can think of that as our variable. We have milk that exists, which is like the content, the data, or the facts, okay? And then we're just going to add the milk to the glass cup, and the glass cup now contains milk, right? So that's the process of something called assignment. So the act of pouring the milk into the empty glass is an assignment. That is, the effect is that the glass container now contains or is assigned the milk or the data. So we use the equal symbol as the act of pouring the right side into the left side. That is the assignment operation. So the equal sign is just an operator. It's a symbol. The symbol in this context is assignment. So x, like in math, x equals 2, y equals 3.14, and then z is just equal to x plus y. Okay? So when we're creating variables in JavaScript, we do something called declaration. So we declare them. So we have here var x, y, z, semicolon. So we're going to declare our 3 containers. And we can declare multiple containers at the same time by just separating them out with a comma. And then we can assign them later on in the next lines of code. We can say, okay, well, I want my container x to be equal to milk. That is, I am pouring milk into container x. This is how these assignments are going. And so y is just, okay, I'm going to say y equals orange juice. So I'm pouring, you can think of it as that, or assigning orange juice into the container y. And so for z, we have the string pineapple on pizza is delicious. So we're pouring facts into container z. Would you look at that? You know, facts. Okay, very simple facts. Okay. So this is what it could look like, right? We're declaring our variables x, y, z. So we use the var keyword to declare our variables var x, comma y, comma z, semicolon. That's the end of our statement. And then here we have x equals 1, semicolon. That's the end of that statement. So I'm assigning 1 to x. I have y equals 2, semicolon. Okay, so I'm assigning 2 to y. Okay, so in this case, what we call this assigning literal values. The reason why we call them literal values is because we are assigning the literal values 1 and 2 into some variable. Okay, and so here we have z equals x plus y. So this is a computation and assignment. So we're going to take x, we're going to add to it y, and then we have z. So whatever x plus y is going to become z. Just like math. Very, very simple, right? Nothing too hard. If you've ever done math, then this is pretty straightforward. Okay, values. There are 2 types of values here that we can talk about. They have fixed values and we have variable values. So a fixed value, we call them literals because they're literally just there. That's how I like to think about it. They're just literally there. Variable name values are variables. You don't really know what that value is unless you compute it first and figure out, oh, what is this variable actually? What's the value of this variable? So here's some examples of some literal values. They are literally these values. The literal value -1, -1. This is a hex number, 0xFFFF. That is a literal value. We have 3.14, which is a decimal number. The literal number is 3.14. Am I making that clear? Why we call these literal values? They're literally there, right? Here's an example of a JSON object, which we're going to talk about later, which has this crazy syntax. We have this curly brace, and then a key called name, Bob Dylan, and then we end the object there. So this is an example of a literal object. We have the string hello here. We have true, false. These are Booleans. We have an array with literal values 1, 2, and 3. And we have this literal text. Literal text, very cool. And here's some examples of variables. Okay. So here I have a variable x. And I'm assigning the value x, these literal values, one at a time. So x is 0, now it's 1, now it's 1, now it's 2, now it's 3, now it's 5, now it's 8. So if I had you cover this part up and all you had was this to look at, could you tell me what the variable called variable is actually assigned if I blocked this out with my hand? If you couldn't see that and all you could do is see this, could you tell me what variable actually contains, what is the actual value? And the answer is no. You cannot. If I were to cover this part up right here, you couldn't tell me because we just see X. Now, if I can see this code, then yeah, you can answer the question. Okay, yeah, variable is equal to 8 because X is assigned 8, so therefore the variable, this variable called variable, is actually equal to 8. But if I cover this part up, you have no idea because there's no literal value that I can see. So we call this, it's a variable, right? It can be kind of confusing, but I'm not talking about a variable like a variable. I'm talking about a variable as in it's dynamic. We have no idea, right? Unless you know what came before, there's no way you could know. And so that's the distinction between literal values and variable values, or fixed and not fixed. Okay. So here's some examples of some operators in JavaScript. Okay. So these are some operators you've probably seen before. The assignment operator we just saw. A plus sign for addition. We have minus. You could use this for subtraction or negation, depending on the context. The star, the asterisk, is for multiplication. A forward slash, in the context of numbers, again, if you have a number on the left, slash a number on the right, that looks like division, right? So it's division. The double asterisk, this is unique to JavaScript. That is exponentiation. And some other bitwise operations. These are logical operators. So these operators, we call them binary operators. Binary as in it takes two arguments on the left side and the right side in order to perform the operation. That is, in order to use an assignment operator, I must have something on the left and something on the right. If you want to add two things together, I need to have something on the left and something on the right. 1 and 2, that is binary. It means two things. Then we have a unary operator. So the minus sign can also act as a unary operator because you can negate something. You can take a number and then just negate it. That only requires one thing, and that's on the right side. So minus 3, you're taking the literal value 3 and making it negative. It's the negation. And you have this squiggle, which is tilde, which is okay, what's this one? I forgot. I think it's the XOR operator is a tilde. Yes, I believe so. No, it's not. It's not. The XOR is the caret. Okay. So here's some examples of some binary operations. So we declare a variable up here, x. We have y. We have z. Okay. So we're going to declare and do something called inline initialization. So here we just declared x. Here we're declaring y and then assigning it the literal value 1 at the same time. Okay. That's called inline initialization. Okay. So that's the difference between these two. Okay. I'm doing the same thing with z. I'm assigning it the literal value 2. Okay, so I'm declaring it and I'm inline initializing z. Okay, now x has been declared, but we haven't assigned it anything. So here we're going to say x equals y plus 2. This is a form of addition. We have y minus z, that's subtraction. Z times 2, or z star 2, z asterisk 2, this is multiplication in the context of numbers. Y forward slash z is division. This is the division operator in this context. We have 1 star star 2, which is exponentiation in the context of numbers. We have bitwise left shift using the 2 chevrons. This is using 2 angle brackets. We have right shift. We have a right shift with 0 fill. So if you wrap it, we'll just assign 0 to the back. We have bitwise OR. We have bitwise and bitwise XOR. And the tilde is the not operator on bits. So just we'll talk about that. Okay, so here we have var x, so that's cool. We're declaring it. And in here, notice that again, these are the unary operators. We put a minus sign, but we're not subtracting. We're just negating. So we're taking the literal value 1 and we're negating it. So instead of being positive 1, it's now negative 1. So notice that the context here for this minus sign is the negation. And so here I'm taking x and I'm assigning it to minus x, which is the negation of the variable x. So you can negate variables. So that's cool. And in here I'm saying x equals to bitwise not of 1, which is just taking 1 and then looking at the bits and then knotting it. Okay. Okay, so now we have some comments. So let's see what time it is. 6:56. Okay. So let's see how far we can go. All right, or does anybody have any questions so far? No questions yet? Okay. Okay. Comments. So comments are text that is ignored in a program. That is, they're not executed. They don't really do anything. This is just mental notes, that you can put down on your code. This helps the coder with remembering. That's a fun fact. As you're coding something, you come back a month later, you're probably not going to remember why you did certain things. So you might want to write a comment so you can remember. It also allows you to scribe instructions on your code. You can be like, hey, if you want to build this piece of code, follow these instructions. You can write instructions to do that. You can also describe the operations. Looking at these operations over here, these can sometimes look kind of weird. So maybe you put in some comments saying what it is that you're trying to accomplish there. And also, if you took code from the internet, right, like from Stack Overflow, for example, like a function or something like that, it's good practice for you to link where you got that code. If not, that's technically plagiarism, right? So if you found something on Stack Overflow, even if you did modify it, sometimes it's a good idea to link it just so like in the future, if you ever need to come back to it, be like, why did I do it this way? You can look at the Stack Overflow to see why it is that you did something. Okay, so here's some examples of some comments. So here is like my regular code, and you'll notice that the comments are in this green color. So we have, this is a single line comment. That's pretty simple. You can also comment out your code, right? So if you want a piece of your code to be ignored, you can put 2 forward slashes, right? And now you can see that this line of code has been commented out, i.e. it's been ignored. Okay. Okay, now here we have some comments that we put on top, so you don't have to write it on the side. You can put it on the top like this too, so comments can go above some code. Or they can go next to some code, right? You can write the comment next to the code. And if you need more than one line, because you're about to, drop a paragraph worth of text, then you can use a multi-line comment that looks like this. Okay, it's a / ***, and if you hit enter, if you're using a smart editor, it can autofill these stars for you as you're hitting enter. Okay. Cool. So let's just touch some of this stuff that we've been doing right now. Okay. So I'm going to create a file here. I'm just going to call it code.js. I'm just going to write some code here. Open up this file here. Okay. And let's do some of the stuff that we're talking about. So I'm going to create a variable, var x. I'm going to assign it to number 2. So I am assigning the literal value 2. Okay, cool. Not too bad. So we have, let's say, var y, which is equal to, let's say, 4. Okay, so I am going to assign the literal value 4. Okay, all right, not too bad. Now I want to do some computation. Let's say I want to add these two numbers together. Okay, so I can say, add them. Okay, let's do x plus y. Okay, cool. This doesn't really do much. I mean, it is adding them. Okay, but in JavaScript, you're allowed to do this. So if I run this node and then pass in that, you can see it ran, but nothing really happened. That kind of sucks. If I want to see it on the console, I need to print it out. So I can wrap this all in a console.log, and I wrap it like this. Okay, right here. So this prints the result of x plus y. Okay. Now, once you have Node installed on your computer, you can run your JavaScript code by doing the following. Node, which is the program we're using, Node. And then all you have to do is feed it the JavaScript file. So what is it called? It's called code.js. Okay, and you hit enter, and it'll run your code. In this case, 4 plus 2 is 6. All right, cool. Right? Not too bad. So you can see we have some code here, we have some comments, and then we're printing out the results. That's not too bad. Let's do one more. So let's say I create a variable called result. I can assign this x plus y. Okay, so result contains the result of x plus y. Cool. Now if I run this, nothing happens. That's kind of boring. So what we should then do is we should just log it. So we say console.log, and we pass in result. Okay. We run that again. We get 6. All right, not too bad. So you can see how we can use intermediate variables sometimes, like this result, in order to contain the result of some operation, say, and then we can use that to do something with it. In this case, I'm just going to print out the result. That's not too bad. Okay, not too bad. Now, the process of actually creating these variables, like it says x, y, and I call this one result, so that's interesting. So the question should now be, what can I name my variables, right? What can you name your variables? So the variables are actually what are called identifiers. Okay, the act of actually tagging something is called identifying. Okay, so identifiers are just labels, IDs for variables, keywords, functions, and classes. Okay, they must start with a character or symbol. So a character is anything that's from A through Z. Okay. You can also use a symbol, which is called the lodash or the underscore, or you can use a $sign at the starting of your variable. Okay, and it must be followed by one or more characters or symbols like the underscore and the $sign. And it is case sensitive. Okay, so let's look at some examples here. So here we have var x. So this is legal. Starts with a character, that is x. This is illegal right here because you're starting with a number. That's not A through Z. 2 is not in A through Z. Therefore, it is illegal because it starts with a number. This is legal, but uncommon. That is that we have this variable here, or this character x, followed by an underscore and another character. It totally works, but you don't really see that in JavaScript. Okay? Here we're starting this variable with an underscore, a symbol. So this example here starts with a symbol followed by a character, usually reserved for special usage. Okay? So here this is illegal because the token here, we're using a asterisk in front of the x to declare the variable. You cannot do that. This is illegal because you can only have A through Z, a symbol, which is $sign or underscore at the very beginning. Here, this is legal because our variable starts off with a symbol, okay? And the symbols that we can use is underscore and $sign, so this is totally legal. And this is usually reserved for special usage and communication. For example, jQuery uses the $sign. And here's another example of something that's legal. You have a symbol, character, that's totally fine. And then we have case sensitivity. Lowercase variable name is different from uppercase name. These are completely different. Okay? So case sensitivity matters. So then we have, for casing, you have to ask, okay, so should I do everything lowercase? Should everything be uppercase? Or what should I do? So there are different types of casing. Snake case, where you have a word and then you have an underscore that's supposed to represent like a space, um, followed by another word. This is called snake case. This is what's used in C and C++. It's valid in JavaScript, but not really used anymore. Okay, so we don't really use snake casing in JavaScript. Okay, but you can still do it, but it's if you work for a company, they're gonna be like, nah, we don't do that here. Okay. Camel case. This is what's used by JavaScript. That is, it looks like a camel, right? You have the camel humps. You have little humps or whatever. It's kind of why they call it that. So camel case. You usually start off with a lowercase symbol, okay? And then every word, the first letter of the following word is going to be uppercased. So you have camel and then case. And then we have this right here is called Pascal case or uppercase camel case. That is that the first letter is actually going to be uppercase, and then you have every other word is going to be uppercase. So Amar says that I've heard that last one as Pascal. Yes, this is Pascal case because in the Pascal language, this is how casing was done. Yes, that is absolutely 100% true. These are both considered camel casing, but this one just starts off with an upper. It's also called Pascal case because that's how they do it. Okay, so here's an example of why you should use some type of casing convention. Because you can see here is an example of an identifier. Now this totally works, but it's discouraged because it's hard to read. It's hard to read this variable. Everything is lowercase. That's really hard to read. But you can see here in this variable, the first letter of every word is uppercase, and this makes it easier to read. So we're using an uppercase letter for the start of a new word. Now, the only exception to this rule is when you're dealing with classes. Classes always start with an uppercase letter. So here with class, some creature, and you can see that it starts with an uppercase. Okay. So a class starts with an uppercase letter and follows the camel case pattern. So then some creature is a word, and the first letter of the creature word is a C, and so this one's uppercase. So that's about it for that one. Okay. So I'm over time. It's 7:07. I'm going to end it here on data types. So, but before we go, I'm just going to show you how this is going to work out. So with these slides, once we go over these data types, we have activities at the very end. Okay. These activities, I will show you some examples. I will not do the activities that are on the slides. These activities here are for you. These are for you to do on your own time to help you, practice a little bit of some of these things that we're talking about. So I would encourage you to use the activities to kind of act like homework, and then just try to do them on your own. And if you run into any problems, use the Discord server and ask questions. And then on the following time we meet, which is probably going to be Wednesday, we will meet Wednesday at 6 p.m. If you have any questions or concerns about the activity, let me know. I'll ask questions, and then I will show you the solution the next time. Will you be posting the note on Discord? Yes, for these slides, they will be on Discord. I think they're already there under important links. So I'll show you the Discord server here under important links. You'll see it right here. It's right, no, right there, right here, Google Drive. So it's going to be right there. Okay. Okay. And then what's really cool about these slides that I made is that at the very end of the slides, okay, these are all solutions. Okay, these are all going to be your solutions. So the solutions here you can see to activity, whatever. Okay, these are all the solutions. So the following slides contain the solutions to various activities. Try them out yourself first before looking at the answers. Okay. So these are all the solutions that we'll see. So there's going to be some complicated ones that we'll see as we go along. Okay. I think these are going to be the most complicated ones, is like using recursion and something called tail recursion. Okay. Cool. And then somebody's asking, which JavaScript extension did you install on Visual Studio? I don't believe I have everything is just pre-baked in. If you want to see my extensions, these are the ones that I have currently installed right here. Um, I don't think I have something specific for JavaScript other than what's built in. Um, yeah, it's just the default stuff. If you're not getting any kind of like highlighting, make sure that you actually have the extension .js for JavaScript, and you should get nice looking colors here. You should be good. Okay. All right. If you totally want to, by all means, read ahead. We were only a few slides before the first activity. Um, and let's just talk about data types. So you guys want to go ahead and read ahead, by all means, go for it. And then try out the activities. Okay. If not, that's it for me. I don't want to have the recordings be like 2 hours because I don't want to burn you guys out. Unless you guys want to go for something longer. If you think, oh, 1 hour is not enough, let's go for 1.5 hours. I'm totally down for that. I just don't want to burn you guys out, which is why I decided not to do it every day. Decided to do it every other day. This gives you Tuesdays and the Thursdays and the weekends to try things out yourself. Especially right now, this part may seem kind of boring because it's like, ugh, gotta do all this stuff. But I promise you, just stick with it because things are going to ramp up real fast. Okay, you're going to learn JavaScript in about a week. Okay, so this entire week will be dedicated to JavaScript. So we're gonna go through all 100 whatever slides. So Herman's saying that 1.5 hours is good. Yeah, okay. Well, it all depends on everybody. We'll stop here for now, and then on Wednesday, if you guys think 1.5 hours is okay, then I will do 1.5 hours. So yeah, on some topics may go over, because especially when we get to React, it gets very complicated. So we might go over 1.5 hours. So yeah. So that's definitely a possibility. So if you ever have to just leave, you can go ahead and leave, and you can come back and finish off wherever you left off. Okay. So I encourage you to look at the slides, try things out, especially if you're new to programming. Read the slides all over again, watch the video again, ask questions in the Discord server, and yeah, that should be it. That's it for me. We'll go start up here. So yeah, with that, I will say thank you, and I will see you guys at Wednesday at 6 p.m. Okay. And yeah, hopefully you guys liked it. Let me know what you guys think. And yeah, I hope you guys continue coming, and hopefully you make it through the entire summer. And by the end, hopefully we have some pretty badass software. All right. So thank you everybody, and I'll see you guys on Wednesday. Bye guys.